Hello there, and welcome to the Sleepy Nature Channel. Did you know that a flower doesn't just grow its petals randomly? It builds them the way a mathematician might draw a perfect pattern, folding and unfolding according to rules so ancient they predate every human civilization. A single daisy, nodding in a summer field, is carrying inside it a geometry so precise that scientists have spent centuries trying to fully understand it. And yet, to a bee landing on that daisy, it is simply home. Tonight, we are going to wander very slowly through the world of flowers and the beautiful symmetry hidden inside them. We'll visit petals that mirror each other like still water. We'll sit with roses whose spirals follow the same quiet math as galaxies. We'll breathe with orchids that have been growing their perfect shapes for millions of years. There is nothing to rush toward. There is no destination tonight. Just softness and light, and the slow opening of one flower after another. So find a comfortable position, let your shoulders drop. Take one long, easy breath in and let it go. You are safe and you are warm, and the flowers are already waiting for you. Imagine you are lying in a meadow just after dawn. The grass is still cool beneath you, and the air has that particular quality it only has in early morning, thin and clear with the faintest sweetness in it. Around you, flowers are opening. Not all at once, not with any fuss. They open the way sleepy things open slowly, each petal uncurling like a hand relaxing after a long time being held tight. The first flower you notice is a simple daisy. It is so close to you that you could reach out and touch its white petals without moving very much at all. And as the light grows and touches it, you begin to see something you may not have noticed before. Each white petal is almost perfectly identical to the one beside it. Not quite. Nothing in nature is ever quite exactly the same, but close enough that the whole flower has a feeling of deep, settled order. There is a kind of peace in that, in something so quietly organized. This kind of arrangement has a name. It is called radial symmetry, and it simply means that a flower's parts are arranged evenly around a center point, the way spokes come out of a wheel. If you were to draw a line through the middle of a daisy in almost any direction, you would find one half that looks very much like a mirror of the other. The flower is balanced all the way around. Most of the flowers we love best, daisies, sunflowers, buttercups, chamomile, carry this kind of symmetry. They are, in a way, living circles. But there is another kind of symmetry in flowers, and you find it in the ones that have always seemed the most mysterious. The orchid, the snapdragon, the sweet pea. These flowers have only one line of symmetry down their center. One half mirrors the other, the way your left hand mirrors your right. Scientists call this bilateral symmetry, a word that just means two sides. And there is something deeply familiar about it, something that feels almost like recognition, because this is also the symmetry of faces, your face, the face of almost every animal you have ever loved. The snapdragon is a gentle example to begin with. If you have ever pressed the sides of a snapdragon flower and watched its little mouth open and close, you have felt its bilateral symmetry in your fingers. The two sides move together, hinged at the center, perfectly balanced. Children love this, and there is a good reason. That balance feels satisfying in a way that is almost impossible to explain. It simply feels right. The violet is another flower with this quality. Its 5 petals are arranged so that 2 are at the top, 2 are at the sides, and 1 hangs down at the bottom like a small landing platform. If you draw a line from top to bottom through the center of a violet, one side becomes the mirror of the other. That lower petal, the one that juts out a little, it is not just decoration. It is a landing pad shaped exactly right for a bee to touch down, turn, and find its way to the nectar inside. The symmetry is a map. The flower drew it for visitors it has never met. Some flowers have symmetry that changes as you look more closely. A rose, seen from above, appears radially symmetrical. All those petals spiraling out from the center in a way that feels endlessly balanced. But each individual petal, if you look at it alone, is slightly asymmetrical, wider on one side than the other, curved more on one edge. The symmetry of the whole rose is built from parts that are each slightly imperfect. This is not a flaw. It is how the rose became a rose. Through accumulation, through thousands of tiny individual decisions layered over each other across millions of years. The way a flower's petals are arranged inside the bud, the way they are folded and tucked before they open, is called vernation, and it is one of the ways a flower's symmetry first announces itself. In some flowers, each petal just overlaps its neighbor on one side. In others, the petals are folded into a kind of pinwheel, each one tucked under the next in a spiral. Open a rosebud very gently, and you will see this spiral packing, every petal laid against the others in a precise, orderly sequence. It looks like origami. It feels like patience. The number of petals a flower has is also part of its symmetry. Lilies often have 6. Buttercups have 5. Daisies appear to have many, but if you count the petals on a daisy, those white ray petals around the yellow center, you will often find numbers like 13, 21, or 34. These are not random. They belong to a sequence that mathematicians call the Fibonacci sequence, where each number is the sum of the 2 before it. 1, 1, 2, 3, 5, 8, 13, 21, 34. Flowers count in Fibonacci numbers because this arrangement fits the most petals into the least space without any 2 petals crowding each other. The flower found the answer to a packing problem that humans took centuries to understand. There is something so restful in this thought that the flower was not trying to be beautiful. It was trying to be efficient, and the efficiency turned out to be beauty. That the two things are, in some quiet way, the same. The sunflower makes this visible in the most spectacular way. Look at the center of a sunflower, and you will see the seeds arranged in 2 sets of spirals, one spiraling clockwise and one counterclockwise. Count one set of spirals on an average sunflower, and you will likely find 34. Count the other set, and you will find 55. Both numbers are in the Fibonacci sequence. The sunflower is growing its seeds as efficiently as it possibly can, and the result is a pattern so beautiful that artists have been drawing it for thousands of years. The chamomile, lying there in the morning grass near you, is a smaller version of the same thing. Its yellow center button is packed with tiny flowers. Each of those small yellow dots is actually a complete flower, called a disc floret. They are arranged in the same Fibonacci spirals, just miniaturized. The white petals around the edge, those are also individual flowers called ray florets. A chamomile isn't one flower, it's hundreds, arranged in a perfect symmetrical community. The morning light is getting a little warmer now. You can feel it, just slightly, on your face. The grass has dried enough that it isn't cold against your hands anymore. A bee is moving somewhere nearby. You can hear it more than see it, going from flower to flower in a slow, unhurried survey of what the morning has to offer. The bee, you might know, can see ultraviolet light, which is invisible to human eyes, and many flowers that look plain white or yellow to us are actually decorated with ultraviolet patterns, lines and dots leading toward the center, like runway lights or trail markers painted for an audience we are not part of. These patterns, called nectar guides, are almost always symmetrically arranged. They reinforce the flower's symmetry from the bee's point of view, making it even clearer where the center is, even more inviting, even more organized. The idea that a flower is decorated for someone else, for eyes we don't have, is one of those thoughts that is somehow both very small and very large at the same time. The meadow is fuller than it looks. There is more going on in the light than we can see. If you're enjoying this gentle journey through flowers, feel free to leave a comment below. It always means a great deal, and it helps more people find their way here to rest. A tulip, pushing up from the ground somewhere at the meadow's edge, is still closed this morning. Its 3 outer petals and 3 inner petals alternate in a tight, elegant arrangement. When it finally opens, in an hour, maybe 2, when the sun has warmed it enough, it will open in almost perfect symmetry, those 6 petals spreading out in a balanced cup. Tulips were so prized for this perfection centuries ago that in the Netherlands, during what is now called tulip mania, a single rare tulip bulb could cost more than a house. People understood, even before they had words for symmetry, that there was something profoundly right about that shape. The poppy is more relaxed about its symmetry. 4 large, papery petals arranged around a dark center. They look symmetrical, but hold a certain casual quality, a slight waviness in the petal edges, a small tilt one way or another. The poppy knows it is beautiful and does not try too hard. It just opens in the direction of the sun and lets the light do the rest. The morning is fully here now. The dew is gone from the petals closest to you. Somewhere far across the meadow, a lark is singing, its notes rising and falling in a kind of symmetry of their own. You can breathe in slowly and catch the lightest sweetness. Chamomile, grass, something floral you can't quite name. Everything is still. Everything is orderly in its quiet way. The geometry of flowers, when you start to pay attention to it, is one of those things that fills the world with a gentle sense of reliability. Wherever you are, whenever you find a flower, it will be carrying its symmetry with it. The same rules, the same patterns, the same beautiful mathematical order that has been there since long before any of us were here to notice it. That is a comforting thought. The flowers have been keeping these patterns safe for a very long time. You have moved gently to sit at the edge of a garden. It is later in the morning now, the kind of soft mid-morning when the light is warm but not yet strong, when shadows are still long and blue and the world has a comfortable, unhurried quality. Around you, the garden is full and quiet, and everywhere there are flowers. The rose is the flower people tend to think of first when they think of beauty. And there is a very specific reason for this. The rose's symmetry is not just visual, it is architectural. When you look at a fully open rose, you are seeing something that took evolution a very long time to build. The petals spiral outward from the center in a pattern that is both radially symmetrical and organized according to the Fibonacci sequence. The innermost petals are small and tightly curled. The outermost petals are wide and open, angled to catch as much light as possible. Every petal fits exactly against the ones beside it, without wasting a single millimeter of space. The wild rose, the kind that grows in hedges, the ancestor of all cultivated roses, has only 5 petals. This is the simplest version, and in some ways the most perfect. 5 petals arranged in a pentagon, each separated by exactly 72 degrees from the next. If you drew a line from petal tip around a wild rose, you would trace a perfect regular pentagon. And inside that pentagon, if you drew lines between the petal tips, you would find a pentagram, that 5-pointed star that has fascinated mathematicians and mystics and artists for thousands of years. The wild rose draws a pentagram. It has always drawn a pentagram. It does not know this, and it does not need to. The gardenia, white and heavy with fragrance, opens in a different way. Its petals spiral like a pinwheel, each one curling in the same direction as the last. So the whole flower has a gentle sense of rotation, of motion that has just been stilled. Gardenias were named for Alexander Garden, an 18th century Scottish botanist who spent years studying plants in South Carolina and sent specimens back to Europe. He never expected a flower this beautiful would carry his name. But the gardenia does, and it opens every summer in spirals that look like something slowly, softly unwinding. The peony is generous with its petals. A fully open peony can have over 100. They are layered in rings, each ring nested inside the next, and the whole arrangement is so full and so lush that it looks almost impossible, too large, too abundant. But the symmetry is there, underneath all that abundance. The outer petals are the largest. Each inner ring is slightly smaller. The center is a compact arrangement of smaller petals still, with the stamens, the pollen-bearing parts, tucked inside. The peony is a lesson in how symmetry can accommodate extravagance. You can be perfectly organized and still be overwhelming in the best possible way. You can hear the garden breathing, or perhaps that is you, your own breath slowing down, settling into something easier. The air here is thick with scent, layered the way music can be layered, rose and lavender, and something green and grassy underneath it all. The lavender, growing in a long, low hedge at the garden's edge, has a different kind of symmetry, a vertical one. Each stem is topped with a spike of flowers, and those flowers are arranged in whorls, rings of 4 or 6 tiny florets set at intervals along the stem. The bilateral symmetry of each individual lavender floret is so small you would need to look closely to see it, but the overall effect, all those purple spikes, all those whorls stacked one above another, gives the plant a calm, ordered quality that seems to slow everything down around it. Lavender has been placed in linen and pillows and beside beds for centuries. There may be a reason beyond its scent. There may be something about its symmetry that feels to the eye like rest. The iris is one of the most structurally complex flowers you will find in any garden. 3 large petals hang downward. These are called the falls, and 3 smaller petals stand upward. These are the standards. They alternate in a precise radial arrangement, so that, seen from above, The iris forms a perfect six-pointed star. But each individual petal also has its own bilateral symmetry, and some iris petals are decorated with patterns, lines of color, patches of yellow or white, small structures called beards on the fall petals that are themselves symmetrically arranged. The iris is symmetry nested inside symmetry. It is a flower that rewards very close attention. If you enjoy discovering these small moments of wonder in nature, you might want to check out the playlist. There are many more gentle journeys waiting there for quieter evenings. The morning glory opens fresh every single morning and closes by noon. Each flower lives for only a few hours, and in those hours it is a perfect trumpet of violet or blue or pink, its 5 petals fused into a single funnel, its symmetry so clean and simple that it looks almost designed. The morning glory grew its particular shape to fit a particular kind of bee. The shape of the flower matches the shape of the bee that pollinates it so precisely that the two evolved together, each shaping the other over thousands of generations. The symmetry is a conversation written in the language of shape. The nasturtium is one of the few flowers where the bilateral symmetry creates a sense of direction, a kind of visual arrow. Its 5 petals are arranged so that 2 are at the top and 3 at the bottom, and the lower petals have long streaks of color called nectar guides pointing inward. The whole flower leans slightly, the way a signpost leans toward what it is pointing at. A bee landing on a nasturtium knows immediately which way to go. The flower has done all the work. The bee just follows the map. The hydrangea is a flower that plays a particularly beautiful trick with symmetry. Each of the large showy flowers you see in a hydrangea cluster is not, strictly speaking, a true flower. It is a set of sepals, the parts of the plant that protect the bud, enlarged and colored to attract pollinators. The true flowers, tiny and often invisible, are hidden in the center of each cluster. So, the hydrangea's symmetry, those large 4-lobed or 5-lobed showy structures arranged in a domed cluster, is an advertisement, a kind of symmetrical beauty built entirely for other creatures. The hydrangea dressed up for visitors. The real flower is safe and quiet inside. The forget-me-not is perhaps the smallest flower to carry a full and perfect symmetry. 5 petals, each round and soft, arranged in a flat wheel of pale blue around a yellow center, so small it could rest on the tip of a pencil. The forget-me-not is not trying to be impressive. It is just trying to do what it does. Open in the light, close at night. Offer its tiny center to whatever small insect finds it. Its symmetry is the symmetry of simple things done well, of doing exactly what you are supposed to do, no more and no less, every single morning. The garden is warm now. The shadows are shorter. A butterfly, orange and unhurried, moves through the roses in a path that seems totally random, but probably isn't. Somewhere, a garden sprinkler starts its slow tick and sweep, and the smell of wet soil rises clean and deep. You can feel the bench or the ground beneath you. You're not going anywhere. There is nothing you need to do. The clematis climbing the garden wall has 6 petals, sometimes 8, and they are arranged in a symmetry so clean and precise that each flower looks as though it was cut from paper by someone who was very good at cutting paper. The petals are long and narrow, spreading out in a starburst, and the cluster of stamens in the center echoes the petal symmetry. Each stamen is placed as precisely as a spoke. The clematis was bred and cultivated extensively by Victorian gardeners who were fascinated by its symmetry, crossing one variety with another to create flowers with more petals, more elaborate centers, deeper colors. Thousands of cultivars exist now, and every one of them carries that fundamental starburst symmetry at its core. The water lily, if you have ever seen one floating on the surface of a still pond, carries one of the most meditative symmetries in all of nature. From directly above, a water lily is a perfect circle of petals, layer upon layer, all radiating from the pale golden center. The petals at the outermost ring are the longest. Each inner ring is slightly shorter and slightly more closed. The whole flower is a series of concentric circles, like ripples moving inward rather than outward. Water lilies float with a stillness that seems almost intentional, their symmetry reflected doubled in the water below them, so that you see one flower and two symmetries, the real one and its mirror image below the surface. The water lily's roots are in the mud at the bottom of the pond, and its stems can be very long, stretching upward through the dark water toward the light. The flower arrives at the surface and opens. It does not think about the mud it came from. It just opens toward the light and carries its perfect pattern outward into the world. This, perhaps, is the most restful thought of the garden, that the symmetry in flowers is not something they achieve with effort. They simply grow, and the symmetry comes. They do not need to try. They just become what they are, and it is beautiful. The garden fades behind you now. You have moved, very slowly the way you move in dreams, to the edge of a wildflower meadow, somewhere farther out, away from walls and fences and paths. The wildflowers here have not been tended or bred. They have been arranging themselves for thousands of years without any help, and their symmetry is older and stranger, and in some ways more remarkable than anything in any garden. The ox-eye daisy stands tall at the meadow's edge, and its symmetry is the first thing you see. That classic arrangement of white ray petals around a yellow dome center, so familiar and so right that it seems like the template for what a flower is supposed to be. Children in every country learn to draw a flower that looks like a daisy. They draw a circle and then put petals around it, evenly spaced, reaching outward. They have never been taught to draw this. They just know the daisy is so deeply embedded in the human sense of what a flower is that we draw it before we are old enough to know what we are drawing. The yellow center of the ox-eye daisy, that golden dome, is not a single structure. It is a community of tiny individual flowers, each one a perfect small bilateral symmetry, packed together into a dome according to the Fibonacci spiral pattern. The ray petals around the outside are also individual flowers, but they have developed in a different way. Their 5 petals have fused and elongated into that single large petal you see, facing outward, catching light. The daisy is a crowd, organized as a circle with every member doing a slightly different job. The cornflower, intensely blue in the bright sun, has a kind of symmetry that is easy to miss because the flower looks busy and irregular at first. But look more carefully, and you will see it. The outer ring of florets is much larger than the inner ones, and they spread outward in a ring, each one precisely placed. The inner florets are tubular and tightly packed. The whole structure has a strong radial symmetry, a clear center, a clear outward radiation. The cornflower was once so common in European grain fields that it was considered a weed. Now it is rare in many places, and when you find one, it seems intensely precious. That particular blue, that particular geometry, arriving unexpectedly among the grasses. The field scabious is lavender-colored and delicate, its flower head made of many small florets arranged in a cushion, with the outermost florets larger and more spread, giving the whole structure a lacy, irregular look. But the underlying symmetry is always present. The florets are arranged radially from the center, each one bilateral in itself, and the whole cluster sits level and round like a small platform, the way a landing pad might look to something flying overhead. Bees and butterflies love the scabious. It offers an open, welcoming face, a surface symmetrical enough to land on without difficulty. You are walking now, very slowly, through the tall grass. The stems brush against your arms and hands, not unpleasantly. The meadow smells of warmth, of grass baking gently in the sun, and underneath that, the cooler, damper smell of earth. Your footsteps are quiet in the soft ground. The ragged robin is a wildflower whose name captures its appearance well. Each of its 5 petals is deeply cut and divided so that the flower looks almost tattered at the edges. And yet, within this frayed, irregular shape, there is a bilateral symmetry in each petal, a mirror line running down the center of each cut petal. The whole flower has a radial symmetry, despite looking chaotic. It is symmetry expressed through division, through multiplying the complexity of each part, which somehow makes the symmetry feel more alive, less rigid, more like something growing and breathing than something set in stone. The bird's foot trefoil, which grows low in the grass, has small bilateral flowers in yellow or orange, and they grow in clusters at the top of the stem. Each individual flower is shaped like a tiny boat with an upper petal, the sail, called the standard, 2 side petals, the wings, and 2 lower petals fused into a keel at the bottom. This structure, standard, wings, keel, is the same structure found in all the flowers of the pea family, and it is one of the most successful bilateral flower shapes in the plant kingdom. Clover has it, sweet peas have it, lupins have it. The shape is perfect for bees, which are heavy enough to land on the keel and push it down, exposing the pollen and nectar inside. The symmetry is a mechanism. Beauty and function, again, exactly the same thing. If you'd like to share what your favorite flower is, leave it in the comments below. Those little notes are always lovely to find. The clover itself is nearby, of course. A white clover, its round ball of tiny flowers sitting on a long stem above the grass. Each individual clover flower is bilateral, tiny, and sweet. They are packed into the ball in a spherical arrangement, so the whole structure has something approaching a 3-dimensional symmetry, not just radial and not just bilateral, but rounded in all directions at once. The clover ball is one of nature's most efficient structures. A sphere allows the most flowers to be packed into the smallest volume, with every face pointing outward, every flower accessible. It is a sphere made of symmetries. The red clover, slightly larger and more pink than white, does the same thing with more color. Bees that visit red clover need a longer tongue than those that visit white clover because the florets are deeper. Bumblebees, with their longer tongues, are the ones that pollinate red clover most efficiently. The shape of the flower and the length of the bee's tongue have evolved together as if in conversation, each one constraining and shaping the other across thousands of generations. The symmetry of the flower was tuned for a specific visitor. It is a very particular kind of welcome. The sun is at its height now, and the meadow has gone very still in the heat. Somewhere, a grasshopper sings its dry, mechanical song. The grasses have stopped moving. The air above the meadow shimmers just slightly. Everything is settled and suspended in the warmth, and you can feel the light on the top of your head, warm and generous, the way light feels when it is not too hot, but just exactly right. The yarrow, growing in flat-topped clusters, has small white flowers arranged in a dense, level canopy. Each individual yarrow flower is tiny, with 5 petals arranged in a miniature radial symmetry. Thousands of these tiny flowers form the flat-topped cluster, each one perfectly symmetrical, the whole cluster forming a landing platform visible from a great distance. The yarrow's approach is one of multiplication. Take one symmetry, make 10,000 of them, arrange them in a plane, and you have something large enough and flat enough for almost any insect to land on. Yarrow is one of the most visited flowers in any meadow because it is open to everyone. Its symmetry is hospitality. The meadow buttercup, glossy and bright, has 5 petals so precisely arranged in a radial symmetry that each one is separated from the next by exactly 72 degrees. The petals are coated with a layer of cells beneath the surface that reflects light in a particular way, giving the buttercup its famous shine. You may remember holding a buttercup under your chin as a child. A golden reflection meant you liked butter. The shine is not random. It is caused by a precisely layered structure in the petal that acts like a mirror, and that mirror structure is distributed symmetrically across the petal surface, as symmetrical in its microscopic arrangement as the petals themselves are in their macroscopic one. The symmetry of flowers goes all the way down, it turns out. It is not just in the shape of the petals and the number of stamens. It is in the cells inside the petals, in the arrangement of pigment molecules, in the microscopic architecture of the petal surface. Every level you zoom into, you find more symmetry. The flower is organized at every scale simultaneously. The meadow stretches away from you in the afternoon light, rolling gently toward a line of trees at the far edge. The trees are green and still. The sky is very blue and very large. You feel, standing here among the wildflowers, very small and very comfortable, in exactly the way that is pleasant rather than frightening. Small, the way a seed is small. Small, the way a petal is small, and still perfect in its smallness. You are sitting now at the base of a great oak tree. The roots curve outward around you like a broad wooden chair, and you can lean back into the bark and feel the tree's solidity behind you. The oak's canopy is high above, and the light comes through it in moving patches, shifting as the breeze moves the leaves. This is the shaded edge of a woodland, and at your feet, in the dappled light, a whole different world of flowers is living its quiet life. The wood anemone is one of the first flowers of early spring in woodland places, and it is one of the simplest and most beautiful symmetries you will find. 6 petals, sometimes 7 or 8, arranged in a radial symmetry around a center of yellow stamens. The petals are white, sometimes flushed with pink on their undersides, and they move in the slightest breeze, which is why the flower was named for anemone, the Greek word for wind. They tremble without seeming fragile. The symmetry of the wood anemone is not rigid or mechanical. It has a looseness to it, a gentle willingness to move, that makes it seem more alive than a perfectly still flower might. The bluebell is the flower people most associate with English woodlands, and when bluebells bloom in April and May, they turn the woodland floor into a sea of violet blue that photographs cannot quite capture. Each individual bluebell is bilateral, a drooping bell with 6 petal lobes, 3 outer and 3 inner, arranged in 2 alternating whorls. The whole bell curves downward, the opening facing the ground, the way a bell hangs from a tower. This downward-facing symmetry protects the pollen from rain. The flower is its own small shelter, its shape, a functional answer to the question of how to keep dry in a woodland spring. The bluebell's fragrance is released by something called fragrance compounds from its bell-shaped flowers, and the symmetry of the bell is part of what concentrates the fragrance. The curved walls of the bell funnel the scent downward and outward toward the level where bees fly. The fragrance is aimed. The flower is pointing its perfume in a direction. Somewhere in the undergrowth nearby, the wild garlic is in bloom. Flat white flowers above broad, dark green leaves that fill the air with their sharp, clean scent. Each wild garlic flower is a small star, 6 petals radiating perfectly from a center, exactly equal, exactly spaced. Wild garlic blooms in vast carpets across the woodland floor in spring, so that you walk through light and shadow and flowers and scent all at once, and the world feels layered and complex and very full. The primrose grows at the base of the oak tree near you, and it is a more interesting flower symmetrically than it first appears. Each primrose flower has 5 petals arranged in a radial symmetry, but there are actually 2 forms of the primrose flower. One called pin-eyed, in which the stigma, the female part, rises tall in the center of the flower like a pin, and one called thrum-eyed, in which the stamens, the male parts, are arranged in a ring halfway up the tube. These 2 forms are complementary. When a bee visits a pin-eyed flower and then a thrum-eyed one, pollen from the thrum is deposited exactly where the pin stigma can receive it. The symmetry of the 2 flower forms is a kind of lock and key arrangement, each form having evolved to fit the other. The primrose has 2 sexes that look similar, but are mirror images in their internal architecture. The symmetry is on the inside, invisible unless you look. You can feel the coolness of the woodland here. It is not cold, just cool, shaded, comfortable. The light is green and diffused, filtered through 100,000 oak leaves. The ground is soft with leaf litter, and there is the clean smell of damp earth and moss. Everything is slower in here, quieter, as if the trees are absorbing the noise of the world. The foxglove grows tall at the woodland edge, its spire of tubular flowers hanging from the stem in a long, elegant spike. Each individual flower is bilateral, that familiar bilateral symmetry of the bee-pollinated flower, the upper lip and lower lip, the landing platform, and the ceiling. The foxglove's flowers are arranged in a spiral up the stem, which means that when you look at a foxglove, you see a different flower on every side, each one hanging at a slightly different angle, each one offering its bilateral symmetry to a slightly different direction. The overall effect is a kind of three-dimensional symmetry. The bilateral symmetry of each flower combined with the spiral arrangement of the whole spike. Inside each foxglove flower, there are dark spots arranged bilaterally along the lower lip. These spots are nectar guides, the ultraviolet patterns made visible in ordinary light. They point inward toward the nectar with a perfect bilateral symmetry. The foxglove is a cathedral in miniature with decorated walls and a clear pathway to the altar. The lesser celandine, which has become a carpet of yellow stars on the woodland floor in early spring, has 8 or 9 petals per flower, each one long and narrow, arranged in a perfect radial symmetry. Lesser celandine opens fully in sunlight and closes in shade or when the weather is cloudy. The flower is photosensitive, and its radial symmetry is a kind of solar panel, opening wide to receive maximum light, closing to protect its center when the light fades. The celandine tracks the sky. It opens and closes with the day, a small, quiet clock made of petals. A wood pigeon calls somewhere in the canopy overhead, its soft, slightly mournful sound moving through the leaves and fading. The patches of light on the ground shift and rearrange themselves as a breeze passes through the high canopy. For a moment, the light catches the primrose beside you, and the petals glow very briefly with the transparency of yellow glass. The wood sorrel, which grows in delicate clusters near the oak's base, has 5 petals with a bilateral symmetry in each, and they are veined with pale pink lines. Wood sorrel leaves fold at night, and in cold weather, their 3 leaflets dropping like closing hands. This movement is called nyctinasty, a word that simply means night movement. The flower also closes at night, its 5 petals furling back toward the center symmetrically in the reverse of how they opened. Every morning, the wood sorrel reopens. Every morning, the same pattern, the same 5 petals, the same pale pink veins, the same bilateral symmetry. As if the flower is practicing something it has been practicing for millions of years and has not yet tired of. The sweet violet, which William Shakespeare called the emblem of modesty, grows low along the woodland path, its small purple or white flowers nearly hidden under large heart-shaped leaves. The violet's bilateral symmetry gives it a face-like quality. 2 upper petals, 2 side petals, 1 lower petal suggesting eyes and nose and mouth to a pattern-recognizing mind. Violets have 2 kinds of flowers, the obvious ones you see in spring, and tiny closed flowers that never open, produced later in the season. These closed flowers pollinate themselves without ever opening, without any visitor, without any display of their symmetry to anyone. The violet keeps a private life alongside its public one. The playlist is there whenever you want to continue these wanderings. Just look for it, and you'll find many more quiet places to visit together. The ancient oaks in this woodland have seen millions of wildflower seasons. Each spring, the same flowers have returned to the same places. Anemones, bluebells, primroses, violets, carrying the same symmetries they carried before any human walked here. The flowers don't remember this, they don't need to. The memory is in their seeds, folded in so tightly that a seed no larger than a grain of sand contains the complete instructions for rebuilding every petal, every stamen, every spiral, every Fibonacci number, every bilateral line of mirror symmetry. All of it, waiting inside something almost invisible, ready to unfold in the right season. The woodland has opened now into a more open space, a clearing where the sun comes through fully, and in the center of this clearing, there is a small, still pool. The water is dark and glassy, ringed by tall reeds, and on its surface, a few water lilies float in perfect silence. You have found a place to sit at the water's edge, and the stillness here is so complete that you can hear the small sounds. A fish rising somewhere in the deep middle, a reed warbler moving through the stems, the water itself making almost no sound at all. The water lily, as you see it here, is the most symmetrical flower in the plant world. Its petals are arranged in exact concentric rings, each ring a perfect circle, each petal identical to the ones beside it in its ring. A large white water lily can have over 20 petals in its outermost ring, and they are placed with a precision that seems almost mechanical. Yet the water lily grew this way through the same process every wildflower uses: random variation, natural selection, the slow accumulation of tiny changes over millions of years. The perfection was not planned. It emerged. The water lily family is one of the oldest families of flowering plants on Earth. Water lily fossils have been found that are over 90 million years old. The flowers those ancient plants produced were probably very similar to the ones floating in front of you now. The water lily found a shape that worked and kept it. Through asteroid impacts and ice ages and continental shifts and the rise and fall of 100 different kinds of world. The symmetry of the water lily is one of the oldest symmetries you will ever see in a living thing. The lotus, which is related to but distinct from the water lily, carries a symmetry so pure and so associated with stillness and clarity that it became a symbol of spiritual perfection in cultures across Asia. The lotus grows from mud at the bottom of a pond or river, its stem rising through murky water, its flower opening above the surface in a perfect radial symmetry. The lotus petal's surface is covered in microscopic waxy structures that cause water droplets to bead and roll off without wetting the petal. This is called the lotus effect, and it keeps the flower clean, even in muddy water. The symmetry of the lotus is self-maintaining. It repels disorder. The petals stay white. A dragonfly has just settled on a reed stem at the water's edge, not far from you. Its wings are spread wide, perfectly level, perfectly symmetrical. 4 wings in 2 bilateral pairs. The dragonfly's body, long and iridescent, is also bilaterally symmetrical. It rests in complete stillness for a long moment, its wings catching the light, and then it is gone, vanished so quickly it seems not to have moved, but simply to have been somewhere else instead. The yellow iris grows at the water's margin, its feet in the shallow mud, its flowers at eye level when you are sitting down. The yellow iris has the same complex symmetry as the garden iris. 3 falls, 3 standards, alternating. But in the context of the water's edge, with the dark water behind it and the sky reflected in the pool, the symmetry seems even cleaner. The yellow is very bright against the dark. The 3 upright standards and 3 hanging falls make a star-shaped opening, an invitation pointed at the sky. The arrowhead plant, growing in the shallows, has 3 perfectly equal petals arranged in a radial symmetry, as simple and clean as a child's drawing of a flower. 3 petals, 120 degrees apart, white with a yellow center. The leaves of the arrowhead are exactly what their name suggests. Arrowheads, bilaterally symmetrical, the two lobes at the base perfect mirror images of each other. The arrowhead is a plant that has chosen simplicity and carried it through with complete commitment. The reflection in the pool doubles every symmetry. The water lily above the surface has its mirror below, so that you see two flowers, one real, one reflection, perfectly symmetrical to each other. The yellow iris above the water has its yellow iris below. The sky above is the sky below, inverted, and the trees at the pool's edge have their mirror tree roots growing downward through the water. The pool is a symmetry machine. It takes every asymmetry in the world around it and makes it balanced, makes it whole. There is something very soothing about reflections, and it may be related to the same thing that makes flowers' symmetry so restful. A symmetrical image requires less processing to take in. The mind can look at it and know quickly, this is orderly, this is safe, this is as it should be. The brain relaxes, the shoulders drop, the breath slows. Symmetry is a signal that says everything is in its right place. The pond skater moves across the water's surface without breaking it, its 6 legs spread wide in a bilateral symmetry, each pair of legs positioned precisely to distribute its weight without penetrating the surface tension. The pond skater's body is bilateral, left mirrors right, and the circular ripples its legs make spread outward in a radial symmetry, perfect circles expanding until they touch the reed stems and dissipate. Even the pond skater's movement writes symmetry on the water. A heron has arrived very quietly at the far edge of the pool. It stands in the shallows, absolutely still, its neck curved in an S, its long legs motionless in the shallow water. The heron is one of the most patient animals in the world. It can stand in the same position for an hour, waiting. It is bilaterally symmetrical, of course. Almost all animals are. But the heron's symmetry has a quality that reminds you of the flowers. It is completely at rest. The bilateral balance seems to hold it perfectly still, perfectly upright, perfectly present. The pondweed below the surface flowers too, though nobody but a diver would easily see it. The pondweed sends up narrow spikes above the water, and those spikes carry tiny flowers, wind-pollinated rather than insect-pollinated, without the elaborate petal arrangements of the flowers in the meadow. But even these tiny flowers, evolved for efficiency rather than display, have their symmetry. 4 sepals arranged in 2 opposite pairs, 4 stamens. A bilateral symmetry so fundamental it was retained even when the flowers stopped needing to attract any visitor at all. The symmetry of flowers is not just for pollinators, it turns out. It is not purely functional. In some flowers, the symmetry serves no purpose that biologists have been able to identify. It is simply there, as regular as mathematics, as reliable as geometry. Some researchers suggest that symmetry in flowers may be a signal of genetic health. A highly symmetrical flower was grown in optimal conditions from a healthy plant, and its symmetry advertises this. Other researchers suggest that the symmetry is simply a byproduct of the developmental process, that cells which are all following the same genetic instructions will naturally produce symmetrical results. The truth may be both and neither, and something else altogether. The pool is completely still again. The heron has gone silently. The water lilies float without moving. The light has become the soft gold of late afternoon, and the reeds are lit from one side, their reflections stretching long across the glassy surface. Everything here is at rest. Everything is balanced. The afternoon has moved you to a slope facing south, warm and grassy, the kind of hillside where the soil is thin over chalk, and the plants that grow here are small and specialized and extraordinary. These are chalk downland flowers, flowers of ancient grassland that has never been plowed, and they carry symmetries so delicate and precise that botanists travel long distances to see them. The common spotted orchid is one of the glories of chalk grassland, and the orchid family as a whole is perhaps the most remarkable family of flowering plants in terms of symmetrical complexity. There are over 25,000 species of orchid in the world, more species than there are birds and mammals combined, and every single one of them has a bilateral symmetry so precise that the terms biologists use to describe them sound almost like the language of engineering. The common spotted orchid's flower has 6 tepals, 3 outer and 3 inner. 2 of the inner tepals form a kind of hood at the top, curving forward. The 3rd inner tepal, which is the largest, forms the lip, the labellum, which spreads wide at the base of the flower, decorated with pink or purple spots and lines arranged symmetrically around its bilateral axis. This lip is the landing platform. Its symmetry acts as both a visual signal and a map, the spots and lines pointing inward toward the entrance to the flower. The bee orchid is one of the most extraordinary examples of symmetry in the natural world. Its lip is not just bilaterally symmetrical. It is shaped and colored to resemble a female bee. The outline of the lip, its velvety texture, its patterning of brown and yellow and pink, all together create something that looks to a male bee, like a bee that is resting on a flower. The male bee attempts to mate with the flower. In doing so, he carries pollen from one flower to another. The bee orchid's symmetry is a mimicry, a disguise, a beautiful deception. The flower evolved a female bee's body using the same rules of bilateral symmetry that both flowers and bees obey. It found the overlap between 2 symmetries and lived there. The pyramidal orchid, which grows in dense spikes on chalk hillsides, has flowers arranged in a tight conical cluster, each flower bilateral, each one pointing outward from the axis of the stem. The pyramid of flowers is itself a kind of radial arrangement, seen from above. The flowers point outward in all directions from the center, like the petals of a 3-dimensional flower. The pyramidal orchid is small and jewel-like, and smells faintly of foxes, which is not unpleasant in the open air. The hillside is buzzing. The thin chalk soil here supports dozens of species of wild bees, not just honeybees, but solitary bees, bumblebees, mining bees, cuckoo bees. And they are all at work, moving from flower to flower in the afternoon warmth. You can hear the buzzing as a constant, comfortable background, a low hum that fills the air and makes it feel alive. The wild thyme grows in low mats across the chalk, its tiny bilaterally symmetrical flowers in shades of pink and lilac, so small you have to get very close to see their symmetry clearly. Seen up close, each tiny thyme flower has the same 2-lipped structure as the foxglove, the same upper and lower lip, the same bilateral perfection. Thyme was used medicinally in ancient times, and it was associated with courage. Roman soldiers bathed in thyme water before battle. It seems a contradiction. This tiny, quiet flower, with its gentle bilateral symmetry, associated with strength and courage. But there is a kind of courage in smallness, in precision, in continuing to be exactly what you are, regardless of the size of the world around you. The harebell is the wildflower of upland and hillside, its flowers hanging like tiny blue bells from wiry stems. Each harebell flower has 5 petals fused into a bell, the tips of the petals curling outward, giving the bell's opening a 5-pointed star shape. This is both radial and bilateral. 5 points of the star are equally spaced in a radial symmetry, but the bell itself is bilateral when seen from the side. The harebell moves in the slightest breeze. Its stem is so thin and strong that the flower can bend almost to the ground and spring back without damage. The harebell is symmetry that has learned to dance. A small blue butterfly has landed on a thyme flower near you. It sits with its wings folded, showing their undersides, pale, spotted with orange and black dots, arranged in a bilateral pattern. The spots on a blue butterfly's wing are symmetrical in both senses. The left wing mirrors the right, and the pattern of spots on each wing has its own internal symmetry, a bilateral organization of color that makes each wing a small, complete composition. The butterfly opens and closes its wings slowly, like breathing, each movement revealing the brilliant blue of the upper sides for a moment before folding them back into pale camouflage. The salad burnet, a common chalk downland plant, has round reddish flower heads composed of tiny flowers that are wind-pollinated and lack petals altogether. They have no need to attract insects, so they dispensed with the elaborate petal symmetry long ago. And yet, the flower head is round. The tiny flowers are arranged regularly within it, and the leaves, pinnate, with paired leaflets along a central stem, carry their own bilateral symmetry, each leaflet paired exactly with one across the stem. The salad burnet gave up its flower symmetry, but kept its leaf symmetry. It found a different way to be organized. You can smell the chalk hillside now, a dry, warm smell, faintly herbal from the thyme and marjoram, with the sweetness of clover underneath. The sky has become a little hazy, the blue softened toward white at the horizon. The sounds of the meadow below have faded. Up here, there is just the breeze and the bees and the small, precise flowers. The horseshoe vetch is a yellow pea family flower, all bilateral symmetry and landing platform construction, and it grows in exactly the right place for the chalk hill blue butterfly to lay its eggs. The caterpillar feeds on the vetch. The adult butterfly visits the flower for nectar. The bilateral symmetry of the flower fits the bilateral symmetry of the butterfly. The hillside is a community of bilateral things, each one fitted to the others. The eyebright, which is tiny and white and grows very low in the grass, has a flower so small that most people walk over it without ever noticing it. But if you lie down in the grass, which you might do here in this warm and comfortable afternoon, and look at an eyebright flower, you will see a bilateral symmetry of extraordinary refinement. The upper petals are white. The lower lip is white, with purple lines arranged symmetrically, converging toward the center, and a yellow spot at the throat. The whole flower is less than a centimeter across. It contains, in that tiny space, all the same elements as the foxglove and the orchid: landing platform, nectar guides, bilateral symmetry, precisely tuned for its pollinator. The eyebright built a cathedral in a centimeter. The afternoon is warm and slow. The chalk hillside holds the heat, and the grass is the fine, sweet grass of ancient downland, soft enough to lie on comfortably. The hum of the bees is very constant, very soothing, rising and falling slightly as different bees move through the air above you. The harebell beside your ear trembles. The sky is wide and pale and beautiful. You have come now to a garden of a different kind, not an English garden or a meadow or a woodland clearing, but a tropical garden, warm and humid, where flowers of impossible elaborateness open among leaves the size of umbrellas. The air here is thick and rich with fragrance, and the light is different, more gold, more saturated, filtering through the wide tropical canopy in shafts that make the flowers glow from within. The hibiscus is the flower of this place. 5 petals, radially arranged, each one enormous, paper-thin, translucent in strong light. The petals can be red, orange, pink, yellow, white, or any combination, and they overlap at their bases in the same pinwheel arrangement you saw in the gardenia. At the center of the hibiscus, there is a long stamen tube, a single column of fused stamens protruding far out from the flower's center like a bright focal point. This central column has its own radial symmetry, the stamens arranged around it in a brush, the stigma at the very tip. The hibiscus is a flower you could recognize from a great distance because its shape is so clear, so bold, so symmetrically unambiguous. The plumeria, which is used in Hawaiian leis, has 5 petals arranged in a radial symmetry, and each petal is slightly twisted, so the whole flower has a gentle spiral quality. The center of the plumeria is a different color from the petal edges, often yellow or orange at the throat, fading to white or pink at the tips. And this color gradient is arranged in a perfect radial symmetry, the same in all 5 directions from the center. When you hold a plumeria close to your face, the fragrance is overwhelmingly sweet, and the center's warm yellow seems to glow. The plumeria is abundance arranged in a circle. The bougainvillea is, strictly speaking, not a flower at all. Its bright color comes from its bracts, which are modified leaves. The true flowers are tiny and white, tucked inside the bracts. The bracts themselves, though, those brilliant paper-thin structures of magenta or red or orange or purple, are arranged in symmetrical clusters of 3, and the clusters are arranged in larger symmetrical groups. The bougainvillea's display is a symmetry built from leaves pretending to be flowers. It is, in its way, a kind of theater, the theater of symmetry, without the biology. But if you look closely at the tiny white bougainvillea flowers tucked inside those brilliant bracts, you will find the same bilateral symmetry, the same small tube and spreading lips, the same nectar guides, the same fundamental architecture that you have seen in every bilateral flower, from the foxglove to the orchid. Underneath the theater, the true flower is still doing its job, still carrying its symmetry, still shaped for the visitors that will find it. The heliconia, growing in tall, dramatic clumps, has flower structures called bracts, again, modified leaves that are arranged in 2 rows along the stem, alternating, like pages in a book being fanned open. The whole structure is bilaterally symmetrical, the 2 rows perfectly balanced. The true flowers carried inside each bract are small and tubular, adapted for hummingbirds, whose long bills fit perfectly inside them. the hummingbird hovers, its bilateral wings beating in impossible symmetry, and sips the nectar from a flower that has shaped itself across millions of years to fit exactly the length and curve of a hummingbird's bill. The passion flower is one of the most elaborate bilateral and radial hybrid symmetries in the plant kingdom. Its 10 petals and sepals are arranged in a radial symmetry. Above them is a ring of modified filaments called the corona, arranged radially, each filament banded in blue and white and purple. In the center, the reproductive structures are raised on a stalk, 5 anthers and a 3-lobed stigma, arranged with a radial symmetry of their own. The passion flower looks like a mandala. It looks like something designed for meditation. Spanish missionaries in South America saw in its structure a reference to the Passion of Christ. The crown of thorns in the corona, the wounds in the spots on the petals. They named it accordingly. The symmetry of the passion flower was so perfect, so clearly organized, that people saw intention in it. A tree frog has appeared on a large leaf nearby, very green, very still, its bilateral symmetry so clean and so obvious, left exactly mirrors right, that it looks like a rubber toy. The frog's eyes are gold, and they track you very slowly as you look at it. Everything about the frog is bilateral. Its 4 legs, its 2 eyes, its body. And yet it sits on a circular leaf that carries its own radial symmetry, the veins radiating from the stem. Bilateral symmetry resting on radial symmetry. The whole world of shape reduced to 2 fundamental patterns, endlessly combined. The anthurium, which grows in the damp shade here, has a flower structure unlike anything in the temperate world. A waxy, heart-shaped spathe in red or pink or white, from which protrudes a long, tapering spadix covered in tiny flowers. The spathe is nearly bilaterally symmetrical, a broad heart shape, slightly irregular, but clearly organized around a central axis. The spadix curves gently to one side. The anthurium is one of the few tropical flowers that feels slightly asymmetrical, slightly rakish, slightly surprising, as if it started to be perfectly symmetrical and then changed its mind in the last moment. This small departure from perfect symmetry makes it feel somehow more alive, more individual. Please do remember to like this video if it's helping you relax. It makes a real difference and helps more people find this quiet space. The torch ginger is enormous. Its flower cluster can be the size of a human head, a perfect cone of waxy pink and red petals arranged in a tight, precise radial symmetry. Each petal in the torch ginger is identical to the ones beside it, shaped like a narrow paddle, curving slightly outward, arranged in rings that spiral upward toward the tip of the cone. The torch ginger is the most emphatic flower symmetry in the tropical garden, the most insistent, the most geometrically obvious. It does not ask you to look closely. It announces itself from a distance in the pure language of radial organization. The ginger flower, the true ginger, from whose rhizome we get the spice, is much more delicate. Its flowers are bilateral, pale yellow or white, sometimes with a purple lip arranged in a loose cluster. Each individual flower is intricate, the lip formed from modified stamens, the reproductive part shaped and positioned to precisely contact a bee at the right moment. The ginger's flower symmetry is intimate rather than spectacular, a flower for close inspection rather than long-distance signaling. The tropical evening is beginning. The light is turning from gold to amber, and the air has taken on a slightly different quality, thicker, more fragrant, as the day-blooming flowers close and the night-blooming ones begin to open. The jasmine, which has been a tight white cluster all day, is beginning to release its fragrance now, a sweetness that builds and builds in the cooling air. Each jasmine flower is 5-petaled, radially symmetrical, pure white. They open for pollinators who come in the dark, moths attracted by the fragrance, which is strongest at night. The night-blooming cereus, which blooms only once per year on a single night, is preparing to open somewhere in the garden. By midnight, it will have opened into a flower over 30 centimeters across, white and multi-petaled and radially symmetrical, to a degree that seems almost impossibly precise for something that grew in the dark. By dawn, it will be closed again, its single night over. The cereus has been building this one flower for weeks. It will give it to one night and then let it go. The symmetry it spent weeks building will be offered to a few moths in the dark and to anyone who happened to be in the garden at the right moment. And then it will be done. Until next year. Night has come to the tropical garden, and the jasmine is fully open now, its fragrance almost overwhelming in the warm, still air. But you have moved in the gentle way of these journeys to a different night, a northern night where the temperature has dropped and the sky is clear and the stars are very bright above a garden that is resting in the dark. The moonflower blooms at night, and its name is apt. It is large and white and perfectly round when fully open, its radial symmetry made visible in the moonlight. The moonflower is related to the morning glory, and in the same way that the morning glory's 5 fused petals form a trumpet for daytime bees, the moonflower's 10 fused petals form a wide, flat disc for night-flying moths. The flower is essentially a landing platform for the dark. It is the same solution applied twice, in opposite directions, for opposite visitors. The night-scented stock, which grows in cottage gardens and looks almost plain in the daytime, small, 4-petaled, dull purple, opens its fragrance at night like a secret. The fragrance is exquisite and complex and seems disproportionate to the modest flower that produces it. The 4 petals of the stalk are arranged in a cross, a cruciform symmetry. This is the characteristic of the Brassicatiae family, the mustard family, which includes cabbages and nasturtiums and rocket and wallflowers, and all of which carry this simple, elegant 4-petaled cross at their center. The cross is one of the oldest symbols in human culture. The 4-petaled flower was there long before the symbol. We may have borrowed the symmetry from the flower without knowing it. The evening primrose, which is yellow and large and opens from late afternoon onward, is one of the few flowers that scientists have studied closely for the way it gathers warmth. The bowl-shaped radial symmetry of the flower acts as a parabolic reflector, concentrating the heat of the late afternoon sun toward the center where the nectar is. Bees that visit evening primroses in cooler weather are rewarded not just with nectar, but with warmth. The flower is also a radiator. Its symmetry is a lens for heat. You are in the garden, sitting outside in the dark night, and the stars above you are extraordinary. The sky is very clear, and the Milky Way is a soft river of light crossing from one horizon to the other. The stars are so numerous that The familiar constellations are almost harder to find. They are surrounded by so many more stars, all equally bright, all equally still. The rose campion, which grows against a wall of the garden, has 5-petaled flowers in a brilliant magenta, and in the moonlight they are pale and silvery. Each flower is radially symmetrical, 5 petals, each with a notch at the tip, arranged in a perfect wheel. The stems and leaves are covered in white woolly hairs, soft to the touch, and the whole plant has a silvery quality in moonlight. Medieval herbalists called it Our Lady's Rose because its white-silver leaves seem to glow with a gentle light after dark. The jasmine is visible against the dark wall as a series of white stars. Individual jasmine flowers are, of course, 5-petaled and radially symmetrical. They are literally star-shaped, which is why star jasmine is a common name. In the dark, these small white stars seem to float at the ends of dark branches, disconnected from their plant, visible only as the pure geometry of 5 white petals arranged around a center. The white flowers of night are always radially symmetrical, or nearly so. This is not a coincidence. Moth-pollinated flowers have evolved to be as visible as possible in low light, and radial symmetry is the most efficient way to present a large, clearly shaped target. A radially symmetrical white flower can be seen from every direction and caught by the eye of a moth from any angle. Bilateral flowers, which have a preferred angle of approach, are less well suited to the undirected navigation of moths in the dark. Night chose radial symmetry and white. The tobacco plant flowers at night, its long white tubes opening after sunset to release a perfume that travels far in the still night air. Each tobacco flower is a radially symmetrical tube with 5 lobes at the opening, and the lobes are arranged in a gentle star. During the day, the flowers are partially closed and pale and unremarkable. At night, they open fully, and the garden seems to breathe out something sweet. The hawk moth, hovering before the tobacco flower like a tiny hummingbird, is one of the few insects with a tongue long enough to reach the nectar at the bottom of the tube. The flower grew its tube long enough to exclude everyone else. Its symmetry is a password, and the hawk moth knows it. A bat passes overhead, very fast, almost invisible against the stars, gone before you have quite registered it. Bats in some parts of the world are also flower pollinators. They visit large, night-blooming flowers that are pale or greenish, very fragrant, and often radially symmetrical. The bat's face, covered in fur, bilaterally symmetrical, navigating by sound in the dark, is drawn to the shape and fragrance of the flower as surely as any bee in the daytime. Symmetry works in the dark too. The signal is the same. The receiver has changed. The night is completely quiet now. Your breath makes a small cloud in the cool air. The Milky Way turns overhead, very slowly, too slowly to see, and the garden is dark and still. The white flowers glow, the jasmine breathes. The moonflower disk, wide open, points its radial symmetry at the sky as if offering the stars something back. In the morning, the flowers that bloom tonight will close. Other flowers will open. The moths will return to wherever they sleep in the day. The bees will emerge from their hives and nests and burrows and begin the rounds again. And the symmetry will remain. In every flower, in every petal, in every spiral, at the center of every sunflower and every daisy, in the 5-pointed shape at the heart of every wild rose, in the billions of tiny flowers in every meadow, every woodland, every hillside, every garden, all over the world, all following the same patient, ancient, beautiful rules. It is morning again, and you have come to a place you have not visited before. A Japanese garden designed around the principles of harmony and careful observation. The garden is quiet and full of precise, intentional beauty. There is a raked gravel area, very still. There is a small stone lantern covered in moss. And there are flowers placed with an awareness of their symmetry that makes each one feel like a deliberate sentence. The Japanese cherry blossom, sakura, is perhaps the most celebrated flower in the world for its ephemeral beauty, and its symmetry is simple and perfect. 5 petals, radially arranged, pale pink or white, each petal slightly notched at the tip. The notch at the tip of a sakura petal is one of those small details that feel important, like a final touch that turns something good into something perfect. The 5 notched petals arranged in a radial symmetry give the sakura flower a quality of gentle openness. It looks inviting, accessible, unguarded. It does not reach toward you. It simply is open. The sakura blooms for about 2 weeks each year, and during those 2 weeks, entire parks and riverbanks turn pale pink. The Japanese tradition of hanami, flower viewing, is specifically about sitting beneath sakura trees during this brief season, being with the blossoms, noticing them. The word for the practice is gentle and unpretentious. It just means looking at flowers, attending to them, giving them your presence. The symmetry of the sakura is a reason to be still. The chrysanthemum, which is the imperial flower of Japan, carries a symmetry of extraordinary depth and complexity. A large chrysanthemum has hundreds of petals, arranged in a precise radial symmetry, each petal curving inward toward the center in the varieties called incurve, or spreading outward in the varieties called reflex. The petals are arranged in concentric rings, each ring slightly different in petal size and curve, so that the whole flower has a quality of layered depth. You can look at it for a long time and still see new details, new rings of organization. The Japanese have been cultivating chrysanthemums since the 8th century, and the varieties they have developed include flowers with petals that are tubular, spoon-shaped, flat, or quilled, each variety carrying its symmetry in a different way. The tubular-petaled varieties look almost like sea anemones, each petal a tiny cylinder, all of them arranged in the same radial organization. The spoon-shaped varieties have petals that are narrow at the base and widen to a small, round cup at the tip. A tiny spoon pointing outward from the center in every direction. The Japanese iris, Hanashobu, is grown in specific iris gardens during its brief June flowering season, and it carries all the complexity of the iris families, bilateral within radial symmetry. Visitors to these gardens walk along wooden walkways above the iris beds, looking down at the flowers from above, where their 6-pointed star symmetry is most visible. The Hanashobu comes in an extraordinary range of colors: deep purple, violet, lavender, white, pink, yellow, and the falls and standards of each flower carry intricate patterns of veining, stippling, and streaking, all arranged in bilateral symmetry on each petal. The wisteria in the Japanese garden hangs in long, heavy clusters, its bilateral pea family flowers in shades of violet and lilac. The cluster itself, a long tapered arrangement like a bunch of grapes. Each individual wisteria flower has the same standard wings keel structure as the bird's foot trefoil and the sweet pea. The whole cluster is arranged with a bilateral symmetry in the way the flowers are distributed. More at the top, tapering to fewer at the bottom, the cluster balanced around a central axis. When wisteria hangs over a path or a gate, it creates a kind of floral curtain, each element of the curtain perfectly formed, the whole thing together creating a sensation of abundance that is also, in its deeper structure, orderly. The chamomile tea you might be drinking now, if you have one, was made from flowers whose yellow centers are among the most perfectly organized structures in the plant kingdom. Those Fibonacci spirals, those packed disc florets, that radial symmetry of the ray petals around the dome. You are holding in your hand something that grew according to mathematical rules older than humanity, and it is warming you, and it is helping you toward sleep. The flower's purpose in the end became this: to warm and calm a person in the dark. Do check the playlist if you'd like more evenings like this one. There are many gentle journeys there, all waiting quietly. The peach blossom in the Japanese garden opens on bare branches before the leaves come, and its 5-petaled radial symmetry is pink against the gray wood and the pale sky. Peach blossoms are associated in Chinese and Japanese culture with spring, with renewal, with the beginning of things. The 5 petals of the peach blossom, arranged in their simple, perfect radial symmetry on a bare branch, are one of the most beautiful things the year can produce. Simple, perfect, brief, there and then gone. The plum blossom opens even earlier, sometimes in snow, its 5 white petals arranged in the same radial organization, but with a purity of white that against the dark bark and the white snow seems almost to emit light. The plum blossom is the emblem of perseverance in East Asian cultures. It blooms in the cold, before everything else, without protection, without the warmth that other flowers wait for. Its radial symmetry opens in conditions that seem to argue against opening. The plum blossom opens anyway. The morning in the Japanese garden is very still. There is the sound of water, a bamboo tube filling slowly from a spring, tilting forward to pour its water into a stone basin, then tilting back to fill again. This is the shishi odoshi, the deer scarer, and its rhythm is one of the most peaceful sounds in the world. The gradual filling, the tip, the hollow pour, the faint wooden knock as the tube returns. Fill and pour, the water falling in a thin silver line into the stone basin, the surface of the water in the basin spreading its brief circular symmetry, and then stilling again. The moss on the stones is very green in the morning light. The gravel is very carefully raked. The stone lantern stands beside the iris bed, old enough to have its own ecosystem of lichen and moss, and the lichen on its sides is arranged in an approximately radial pattern. Living things grow toward the light, and on a stone lantern in a garden, the light comes more or less equally from all sides, and so the lichen grows outward from its center in something like a radial symmetry. Even things that do not plan to be symmetrical are symmetrical when the world around them is even-handed. The Japanese garden is a meditation on the relationship between human intention and natural form. Every element is placed with care, but the plants are not forced. They grow as they grow, and their natural symmetries are allowed to be themselves, understood and appreciated and arranged in relation to each other. It is a garden that knows what flowers are. It is a garden that has been paying attention. From the Japanese garden, you have traveled far, and you are now in a landscape unlike anything else. The high mountain meadows above the tree line, where the air is thin and cold even in summer, and the flowers that grow here have adapted to conditions that seem too harsh for such delicate things. And yet, they are here. The flowers of the alpine zone are small and precise, and often extraordinarily beautiful, and their symmetry is as perfect as anything you have seen in the warmest and most sheltered gardens below. The edelweiss, which grows on rocky slopes and scree, is covered in white, woolly hair that protects it from the cold and the intense ultraviolet light at altitude. Its white bracts are arranged in a star shape around a cluster of small, yellow flowers. An approximate radial symmetry, slightly irregular, slightly rough-edged, as if the precise geometry of lower altitude flowers has been simplified to something more robust. The edelweiss looks like a flower drawn by a child who got it slightly wrong, but still captures the essential symmetry. It is perfect in its roughness. The alpine gentian is electric blue and tubular, its 5 petals fused into a tube that opens in full sun and closes in cloud or cold. The 5 lobes at the opening are arranged in a radial symmetry so clean that the gentian looks almost mechanical. Between the petals, the sepal lobes create a 5-pointed pattern that echoes the petal arrangement. So the closed bud looks like a 10-pointed star, a pentagonal symmetry within a pentagonal symmetry. The gentian blue is one of the purest, most saturated colors in the natural world. It seems to absorb the sky and hold it. The mountain avens, which grows in rock crevices in the highest places, has 8 white petals arranged in 2 rings, 4 outer, 4 inner, giving a flower that looks like a small sun, its bilateral symmetry replaced by an 8-fold radial organization. 8 petals is unusual in the temperate world. It is more common in tropical flowers and in some alpine ones, as if the extremes of climate have different symmetry preferences. The mountain avens closes its petals around its center at night, huddling against the cold, and opens again when the sun returns. It has been doing this for millions of years, on mountains that themselves have risen and eroded and risen again. The saxifrages, which grow in dense cushions of leaves and flowers, are among the most remarkable plants of the high mountain. Their name means stone breaker. They grow in rock crevices, and their slow growth over years and decades can eventually split the rock itself. The flowers are small, 5-petaled, radially symmetrical, white or yellow or pink. The cushion form of the plant, all those tiny leaves packed into a dense, rounded mound, protects the inner parts of the plant from wind and cold by creating a small, warm microclimate inside the cushion. The mound itself is approximately radially symmetrical when seen from above. The plant's very body shape is organized by the same symmetry as its flowers. The high mountain air today has a quality of absolute clarity. At this altitude, there is no haze, no dust, no humidity to soften the outlines of things. Every rock is precisely defined. Every leaf is sharp. Every petal of every small flower is distinct, its edges clean against the pale sky. The symmetry of alpine flowers feels more obvious here, more geometric, as if the harsh environment has stripped away everything ornamental and left only the essential architecture. The spring pasque flower, which blooms very early in the mountain year, sometimes while snow is still present, has 6 or 7 petals in a deep violet purple, arranged in a cup that opens toward the sun. The petals and the stamens both carry a bilateral axis, but the whole flower is radially arranged, and the large number of bright yellow stamens in the center creates a golden focal point that is visible from a distance across the rocky slope. The pasque flower is covered in silky hairs, like the edelweiss, which trap a layer of warm air around the flower and keep its temperature above that of the surrounding air. The symmetry and the insulation work together. The flower is both beautiful and warm. A yellow-billed chough is calling somewhere nearby, its yodeling cry echoing off the rock faces. You can see it circling on a thermal far above, its red bill and legs tiny spots of color against the gray cliff. The chough has a bilateral symmetry in its body and wings, of course. All birds do. But in the air, it creates something like a radial symmetry as it circles, wings spread, turning in the thermal with a patient, precise motion that mirrors itself every revolution. The mountain ranunculus, a species of buttercup that grows in the highest meadows, has 5 petals in a brilliant, glossy yellow, arranged in the same pentagon of the wild rose and the wood anemone and the evening primrose. 5 petals, 72 degrees apart, glossy enough to reflect the blue of the mountain sky. The buttercup's shine at high altitude comes from the same optical phenomenon as in the valley. That precise layering of cells within the petal that acts as a mirror. But up here, the sky the petal reflects is a deeper, more saturated blue, and the effect is more striking. The mountain buttercup holds the sky in its petals. The dwarf willow, the smallest tree in the world, grows flat against the ground in the highest places, its catkins barely centimeters tall. But even in the dwarf willow, the flowers carry their symmetry, bilateral, organized, the same structure that is found in willows growing tall beside rivers in the valley below. Size changes, symmetry remains. The high meadow in the thin sunlight is a carpet of small, intense flowers, gentians and saxifrages and ivans and ranunculus all together, all different symmetries and all the same. A world of bilateral and radial arrangements, pentagons and stars and crosses and spirals, all compressed into a short growing season, all making the most of the brief summer before the snow returns. You feel the altitude in your breathing. The air is clear but thin, and each breath is slightly more deliberate than at sea level. This deliberate breathing, these slower, fuller breaths, feel very good. The mountain has given you an invitation to breathe more consciously. You are accepting. There is a flower called the compass plant that grows on the American prairies, and its leaves align themselves north to south, using the direction of the strongest light to orient themselves. The flower heads face east toward the morning sun. The compass plant knows where it is. It knows which direction to open. It has a symmetry that is also a navigation, a directional sense built into its bilateral leaves. You are lying down now. You have been lying down for a while, perhaps. Or you are finding that position naturally, the way the body finds it when it has been still long enough, and the day has grown long enough, and the world has become quiet enough. Your eyes may be heavy. The flowers are still with you, somewhere at the edge of thought. A daisy closing a rose holding its spiral, a gentian very blue against a mountain sky. The symmetry you have been carrying through the day, all those radial arrangements and bilateral lines, all those Fibonacci sequences and pentagon arrangements, all those petals furling and unfurling in the light, has settled into something quieter than thought. It has become a feeling, the feeling of things in their right place, the feeling of order that is not rigid, but alive, the feeling of a world that has been making beautiful patterns since long before any of us arrived to notice them, and that will continue making them long after. The lotus in the still pond opens its first petal in the morning. One petal following the angle of the water's surface, perfectly horizontal, pointing at the eastern light. Then another beside it, the same angle, following the same rule. Then another and another, each one placed exactly where it should be, according to laws written into the plant's development by millions of years of trial and finding what worked, what lasted, what was true. By the time the lotus is fully open, 20 or 30 petals have arranged themselves in a perfect radial symmetry around the golden center, and the whole flower is level on the water, and the water reflects it, and the sky reflects in the water, and the lotus is surrounded by reflections of itself, layer upon layer of the same symmetry, going outward in every direction. There is a flower called the moonwort, a small, ancient fern relative that grows in old grasslands and has been there since before the age of dinosaurs ended. It does not flower in the way we usually mean when we say flower. It produces spores rather than seeds, but its fronds carry a bilateral symmetry of extraordinary precision, and it has been carrying that symmetry quietly in field after field for hundreds of millions of years. The moonwort is one of the oldest symmetries still alive in the world. It does not need to know this, it just grows. The symmetry of a flower is its signature, each petal placed where it is placed for a reason that accumulated over millions of years. Each Fibonacci spiral packing seeds as efficiently as physics will allow, each bilateral line inviting a specific visitor to find its specific reward. The flower does not know any of this. It grows, and it is symmetrical, and that is enough. In ancient Rome, a wreath of flowers was placed on the heads of heroes, not as decoration, but as a recognition that the order and balance of the natural world was the highest honor that could be given. The flower was symmetry. Symmetry was rightness. Rightness was what a person of honor embodied. The logic was not spoken, it was felt, the way we all feel it when we stop to look at a flower closely enough to see what it is doing. You are very still now. The flowers in your mind are very still too. A meadow at dusk, a Japanese garden in moonlight, a chalk hillside in the afternoon, a woodland floor in spring, a tropical evening with jasmine in the dark. All of them at rest, all of them holding their symmetries softly in the quiet. The violet that William Shakespeare called the emblem of modesty is closed now, its bilateral face folded into itself, its slight fragrance still present in the cold air of the night garden. The violet has been growing in this particular spot, or one very like it, for hundreds of years. The violet symmetry is 500 years old in this garden at least, possibly older. A white rose is somewhere in the dark outside, its spiral of petals holding the cool night air. You cannot see it, but you know it is there. The symmetry is there, even when the eyes are closed. The pattern exists in the dark. The clover has folded its leaves. The daisy has closed its petals. The evening primrose is open for the moth. The lotus is resting on the water. The edelweiss is on its mountain, breathing the thin air. The gentian is closed against the cold. The honeybee has returned to the hive, where the combs are arranged in perfect hexagons. Another symmetry, another mathematical truth, held in wax by a creature that does not know about mathematics. All of them, all their symmetries, all the patient geometry of the living world. Close your eyes now, if they are not already closed. Let the flowers be somewhere just at the edge of a thought, not quite visible, not quite gone. Let the daisy close. Let the rose hold its spiral. Let the lotus lie on the water. You are warm. You are still. You are safe. The flowers are closing for the night, and you can close too. All the symmetry in the world will be there in the morning, waiting for you, exactly as it has always been. Sleep well. Thank you for spending this evening on this Sleepy Nature channel. If this helped you relax, a like and a comment would mean the world. And the playlist is full of more gentle journeys whenever you need them. Good night.